us. Meanwhile, we are sharing with you a presentation video of our company. Welcome, everyone, and thank you again for being here with us. So the purpose of this webinar is to introduce you to our Shocks Physics Academy and to our program for this year and for the next year. This webinar will be presented by myself, Paola Reyes, in the sales department, and for Paul de Conanc, the research and development manager.
Good afternoon.
But before starting, we want you to know that you have the possibility to ask us all the questions that you may have. You have a chat at your disposal, so to ensure that your question will be taken into account, you need to write your questions and click on the blue bubble, and yes, your question will be appear at the end of the webinar. This webinar will be organized as follows. Firstly, we are going to present you Thiot Ingenierie, who we are, what we do, just in case you don't know us enough. Secondly, we are going to present you the Shocks Physics Academy, and what does it mean? And what are you be able to learn if you come here for train with us? Then we're going to present you the new Shocks Physics Academy program for this year and for the next year. And then we are talking about the social media the social event, sorry, that we organize at the end of every training session. And finally, sorry, you will have the opportunity to ask us all the questions that you may have at the end of the webinar. So yes, as we are shocks physics experimented, today we are able to put all this expertising to our customers through the design and the development of test equipment, but also by testing services. Here you can see some key numbers that define Thiot Ingenierie. We are the first private shocks physics laboratory in the world, and we are a small company because currently we are 14 employees, including experts, engineers, and specialized researchers. We make around between 6 and 8 million euros of turnover. It depends on the year. And more than 60 test equipment have been delivered all over the world. But to better understand the history behind Thiot Ingenierie, let's take a quick look at its evolution since its creation. Historically, when Mr. Thiot founded the company in 1988, it was dedicated only to the development and the design of special machines. And what kind of equipment are we able to propose to our customers today? Well, we have 5 families of test equipment. We have the gas guns. This test equipment allow us customers to characterize the behavior of their materials under impact for aeronautical or military applications. The Hopkinson bars. Thanks to this system, our customers can characterize the dynamic behavior of their materials in compression and traction, subjected to high strain rates or temperature conditions. For automotive industry applications, for military or aeronautical applications. The detonation chambers allow our customers to destroy, to store, or to characterize their explosives. The acceleration generators allow us customers to know if their materials are resistant or not to a given acceleration. And finally, the autofretage machine are dedicated to improve the life cycle of the gun barrels for military applications. And here you can see some examples of customers who trust us all over the world. In 2008, when Mr. Thiot created the first private shocks physics laboratory in the world, in which we carry out test services and numerical simulation for all the customers that don't want to buy a complete system. Our philosophy is to correlate test and numerical simulation. That's why in our shocks physics laboratory, we have our own gas guns and Hopkinson bars. But also we have a team specialized in numerical simulation for dynamic events. So this correlation between test and numerical simulation allow us to support our customers by expertising their problems related to blast and impact through a combined approach between experimental testing and numerical modeling. Everything we can simulate, we can test, we can simulate. Thanks to our 35 years of experience in the design, in the manufacture, and in the analysis of the results, the interpretation of the results, today we are able to put all this expertise at your disposal through the Shocks Physics Academy. And what is the objective of these training courses? Well, you will be able to improve your skills and your knowledge in the dynamic behavior of materials and numerical simulation. These training courses are organized over a period of 2 days and a half, and the originality is that they are entirely held in person, so that you will have the opportunity to come here to our company, to see by yourself, to manipulate yourself the test equipment, so that you will learn in a more efficient way. These training courses are aimed at scientists, numerical simulation engineers, materials, structures engineers, and laboratory workers. The instructors are none other than our engineers and researchers, but also external experts. And at the end of the training, you will pass a final MCQ to validate the acquired knowledge attested by a training completion certificate. We propose a suitable environment. As we are a training organization, we have the appropriate and the necessary infrastructures to welcome people to our company and train them in the best conditions. We have a video conference room dedicated to these training courses so that the interaction between the participants and the instructors will be easier. For each training session, we can welcome a maximum of 15 people for both the practical work in laboratory and the visit to our laboratory. There will be several groups. It depends on the participants. So, Paul, could you please tell us more about the content of these training courses, please?
Yes, thank you, Paola, for this nice introduction. So now it's time to detail a bit more the content of these 4 training sessions that we are proposing next year. So the first one is entitled Introduction to Dynamic Behavior of Material with Associated Numerical Simulation. So it's mainly targeted to people that are working on structures, materials that may encounter some dynamic loading during their life cycle. And as you may know, most material are dependent on what we call strain rate. This is the velocity at which we deform the material. And for most material, their behavior evolves as a function of the strain rate. So if you don't take that into consideration during your design process of your structure or system, then you may make some dramatical mistakes that could lead to failure or overestimating or underestimating the response and the strength of your structures. So the content of this training session is detailed in this slide. So we start with a presentation of different kind of application, of different kind of material, of event that may consider characterizing the dynamic behavior of the materials. And we will, we will then present you different tools that will allow you to investigate and tackle this problem. First, we will present some experimental tools, such as Split-Hopkinson pressure bar. That is one of the ways to characterize the dynamic behavior of materials. Through this presentation, you will be able to design experiments, to specify experiments to subcontractors that will perform the test for you. And then you will be also able to have a critical view on the result that will be given to you, and in order to use them and to being able to calibrate a material model that will be used, for instance, in numerical simulation. And talking about numerical simulation, you will also be introduced to fast dynamic calculation with our partner, which is Abstrao. This is a French distributor of Impetus AFEA. It will introduce you to how to set a model, how to choose the material model, and how to calibrate it into a numerical code. And of course, as Paola told you, you will have some practical session in our laboratory during which you will be able to manipulate our test equipment, our measurement techniques. You will also perform some tests on a simplified impact configuration with dedicated measurement techniques, and also on Split-Hopkinson pressure bar. And at the end, you will have an overview of how important it is to consider dynamic behavior during your design loop of your products. The next training session is called Ballistic Impact on Metallic Materials, Test and Numerical Simulation. So this training session is in partnership with also Abstrao, and Industeel, which is a famous protective steel manufacturer. It is mainly dedicated to people that are designing protective equipment against ballistic impact and metallic equipment, of course. So the content of this presentation is, so you will be introduced to different test cases that are relevant relating to ballistic impacts on metallic material. You will also have a presentation from Industeel that will present you the design of the material that they are proposed, why they are important, why they are resistant, and so on. And then we will have a focus on 3 different case studies, so perforation, adiabatic shear bending, and spalling. So these 3 case studies are failure mechanism that can occur during a ballistic impact, depending on the projectile type, its shape, its materials, the incidence, and so on. And depending on the impact condition, we will be able to face these different kind of failure mechanisms. And these failure mechanisms has to be well characterized if you want your numerical model to be able to predict the appearance of this case study failure mechanism. So for each case study, we will detail you what are the main mechanisms. We will explain to you how to characterize and see how it works through dedicated experimental techniques. And then you will be introduced by the way of modeling this failure mechanism into a numerical code. And at the end, we will give you some example of test and numerical simulation correlation on the test that we will be performing during this training session. Okay, next training session, it's called Measurement Techniques Associated with Impact Configuration. So this one is dedicated for people working in an impact laboratory. The training objectives are mainly to help people to choose the right measurement techniques depending on what kind of value they want to measure, how to set the measurement chain, how to choose the right data acquisition system, how to calculate uncertainties, and also in order to being able to set the whole measurements around an impact configuration. So as I told you, you will be able to choose between different kind of measurement techniques, different sensors, so velocity measurements, strain gauges, high-speed cameras, accelerometer, pressure sensors, PDV, so interferometers, digital image correlation, and so on. You will be introduced to how to set it up, how to configure it into your data acquisition system, how to ensure that what you get is what you really wanted to measure, how to set your measurement chain, and how at the end to have a critical view on your results in order to better analyze them. And we've prepared for you 3 specific practical session on benches that we have developed specifically for this training session, on which you will be able to manipulate the data acquisition system, choose the right measurement techniques, set everything up, and also being able to analyze the results. And of course, at the end, you will be introduced to what you call highly instrumented experiments. So this will be given some example of the kind of experiment and kind of measurement techniques we can get on targets that you are shooting every day in our lab. Okay, next training session, it's called how to use Split-Hopkinson bars in compression and tension. So this one is, of course, dedicated to people that are dealing with Split-Hopkinson bar testing in their own laboratory. So this one, in fact, is a deeper introduction to Split-Hopkinson bar that has been introduced in the first training session. In this one, you will be able to design an experiment, to run an experiment in safety condition, to analyze the result, to define what kind of measurement techniques you can bring to your experiment in order to get the most reliable results on your material behavior, and also to develop a critical view on the results. So it's summarized in this slide. So you would get both training, both theoretical training and practical training, and you will have the opportunity to manipulate on the Split-Hopkinson bars, both in compression and tension, choose the right specimen dimension, specimen shape, depending on the material you want to characterize, depending on the strain rate you want to obtain, and so on. And of course, at the end, we will give you an overview on how to calibrate a material model based on the result that you will obtain on these practical sessions. And also, we will show you some typical, not typical, but uncommon use of Split-Hopkinson bars to perform some material characterization of very specific materials, such as brittle ones and so on. Okay, time to present you the last training session. So how to use Thiot Ingenierie single-stage gas guns. So this one is very specific because it's mainly dedicated to people that have bought us a single-stage gas gun or is in a way in the process of buying one. And in fact, it's mainly dedicated to present you how to set a wall impact configuration around a single-stage gas gun. So you will be introduced to the safety during the launcher use, how to ensure that your operator that will operate this gas gun will be safe in every case, how to design an experiment, which means how to choose, for instance, to design the sabot. The sabot is the piece that accelerates your projectile that will hit the target through the gun barrel. So how to design the sabot, how to choose the right shape, the right material, its weight, and so on, how to optimize it to ensure that it will withstand the acceleration inside the gun barrel. So this is one topic. The second one is internal ballistic, how to design, how to choose the parameter of the gas gun to obtain the right velocity at the end. How to also set and design the tooling. The tooling is the specimen of the target holder. How to optimize its shape, its stiffness, in order to ensure that what you will measure and what you will that the result of this test will be the result of the behavior of the material of the target and not of the behavior of the target and the tooling. So you will have a training session on that. And also one important thing is to choose the right measurement techniques. So it will be almost the same as the previous training session, but here it will be very adapted to specific impact configuration, how to choose the location of the sensor that you want to insert in order to ensure that what you will measure is only the behavior of the material or the structure that you want to test, and not the behavior of the structure plus the tooling. Of course, practical session, so you will be introduced to how to configure a test equipment and the measurement, and you will be performing some tests in our lab. Okay, I think I'm done with the detailed presentation of our training session. So, Paola.
Thank you so much, Paul, for such clear presentation. So as I said previously, at the beginning of the webinar, we try to organize a social event in the most beautiful places in our region. We are based in the Lot region, in the southwest of France, and we are so lucky to have such amazing places all around us. That's why you will not be able to improve your knowledge in the dynamic behavior of materials, but you will also have the opportunity to discover new places. And yes, so here you are a summary of all our training program with its respective dates. But we want you to know that we can adapt to your needs. If, for example, you want us to add a date because the date that we propose are not convenient for you, or for example, if you are interested in another thematic and it doesn't appear in our program, we can adapt to your needs. So please, if you have all other needs, you can contact us. Please feel free to contact us by email, by telephone, but also on our website. And yes, time for questions. So please feel free to ask us all your questions. Just remind you that in order to take into account your question, you need to click at the blue bubble, and the question will be appear in the screen. I don't know if you have questions regarding the organization, the dates, the topics. So you have the core materials. Thanks for your questions.
Okay, so we have a question about the material cards. So I believe that this question is related to I think you are expecting us to give you some material cards at the end of the training session. In fact, no. We will introduce you to how to calibrate material model. The methodology will be explained to you, but we will not give you any material cards during this training session. Okay, we have another question regarding the software that will be introduced during this training session. In fact, this training session are for most of them in collaboration with Abstrao, which is the French distributor of Impetus AFEA. So you will be introduced to set a model in Impetus AFEA, but in fact, the methodology that will be presented to you can be applied to any other software. Okay, are there any other questions? Yes, so we have a question regarding the training dates. So we will display the training date again. Of course, as Paola told you, the whole program is available on our website, so don't hesitate to take a look at it.
Feel free to take screenshot of our summary. Okay, I don't know if you are having another questions. There is still time. Okay, I think it's good.
Mhm.
So thank you so much again for being here, and we hope you enjoyed this webinar and that you found it interesting. And please don't hesitate to let us know if you have another questions. You can contact us by email or by phone if you want.
Okay.
Thank you so much.
Thank you.
Have
Bye-bye.
a good day. Bye.